Hello, good afternoon. I hope everyone can hear me. If not, I'll probably see something popping up into the chat. So let me start by telling you a story. Around 66 million years ago, dinosaurs really had the ultimate bad day. So, with a devastating asteroid impact, a reign that has lasted 180 million years was abruptly ended. So around that time, 70% of the Earth's animals, so including dinosaurs, other animals, birds, and small creatures, died in the aftermath due to climate change or change in the whole environmental settings. So it was the whole aftermath with ash clouds and stuff like that that made things harder for life on our planet. Those who survived are considered the baseline that led to our modern animals. They got through because they were capable of adapting to the new environment, to the new circumstances. So, due to the facts they adopted to the new given facts, they survived. So let us flash forward to 2006. So in 2006, Amazon launched Amazon Web Services, which offered online services to other websites or clients, or even small applications to run into the cloud. In the same year, the competitor of Amazon at that time, Google, launched their Google Doc services. That was an online service that was focusing initially on documents and spreadsheets and so on. Both of them were rather quickly followed by Microsoft, who launched their initial version of Azure. In that time, it was called Project Red Dog, and they launched that in October 2008. Um, 2 years later, Microsoft did a full go live, and they rebranded that Project Red Dog to Azure as we know it right now. Since then, cloud computing has reshaped the way businesses implement their IT solutions. But this transformation is far from over. It is my strong belief that just like with the dinosaurs and other animals, um, businesses and professionals who are not capable of adopting to this new cloud trend will be left behind, as more and more businesses have shifted to include cloud computing in their business plans. And more businesses will shift to include cloud computing in their business plans. So cloud computing really has become the new standard. And by embracing the cloud and by embracing cloud computing technologies, businesses are committing to modernizing their business processes, their IT system for the long term. And basically, that's what we are going to talk about today. So my name is Glenn. I'm one of the founders of Sure Belgium. I'm a Microsoft Azure MVP. I'm also a Microsoft certified trainer, and I have been working with Azure since, yeah, pretty much the early days, let us say 2013. I'm also one of the members of the Azure User Group in Belgium, which we organize our yearly conferences. So a little thing on Azure. So Azure focus 100% on Azure. We have around 80 experts across Europe, and we have offices in Ghent, Helsinki, and Copenhagen. And we recently won Partner of the Year for application innovation and modernization in Finland. But that's not what we're here to talk about today. So the world is filled with ever expanding technology, and many of those technologies rely on cloud computing. So think on digital twins. We have the quantum computing, and you probably all of you already heard of the new AI trend that is going on with ChatGPT, with OpenAI and stuff like that, and all these big technologies really fully rely on cloud computing. So, what is cloud computing anyway? So, cloud computing is the delivery of compute services over the internet, and it allows companies, professionals, and software builders to enable faster innovation and allow them to have faster or better access to let us say services. Um, it's just an on-demand access to a shared pool of computing services. Think servers, networking, storage, applications, and other services. It is super rapidly provisioned, and with a minimum effort, you can interact with these services and start deploying your solutions. So with cloud, we define three different structures. First of all, there's a private cloud where organizations create a cloud in their own data center and are responsible for the full operation of the services they provide. Usually, the private cloud is not accessible for users outside the organization. Secondly, is public cloud. And this is where we will focus mostly on today. Um, Examples of public cloud are Azure, AWS, Google, Alibaba, and all of those cloud providers. So the public cloud is owned by the cloud provider, and the cloud provider is providing resources and services to multiple organizations, to multiple users, to the developers, to the architects that want to build a cloud system. Most of these cloud services are accessible through the public internet. And then there's a combination, and that is called the hybrid cloud. It's a combination of public and private cloud where companies, based on their needs, run their application where it's mostly fitted. So that's that combination of hybrid cloud. I've added some details on what I just said. I believe these slides will be shared afterwards. You can find them on my GitHub if necessary, or they will be shared to the organization. So these slides is just for your reference. So if we take a closer look at the public cloud, this is what a cloud infrastructure looks like. In this example, you'll see here on the screen, you'll see the global Azure infrastructure. So this is what Azure looks like from a data center point of view. So it has 60 regions across the globe, and it's currently the biggest cloud provider in terms of infrastructure and the amount of data centers. There's 200 data centers spread across 140 countries, and they're all connected through a high-speed network. So an Azure region on itself is a set of data center. As already said, they're connected to that big global network with a regional low latency network. So in order to have those fast communications. But maybe this world map is a bit confusing. So let's take a closer look on how a data center looks like. So this is what a typical Azure data center looks like. You can see just like regular data centers, the cloud is just a data center. And if you compare it with the little car in the right-hand corner, you see how big that infrastructure is. So, and if we zoom out a bit, you'll see here that there's multiple data centers within a same region. So these additional data centers that you see here, these in the back with the orange roof, those are what we call, or what is called within Azure, an availability zone. And an availability zone is just a set of um, secondary data centers um, with separate power supply, separate water supply, separate cooling, separate networking, and so on. And they make sure that the entire region of that Azure data center is available all the time. So if something happens in the data center with the gray roofs, uh, Azure always makes sure that your data, your services is spread across the entire data center and the multiple data centers that you see here. And even if you zoom out a bit more, there will be more, a region will always have more than two. So typically it consists of three data centers. So if we would like zoom in back to in the top right corner, you would see that little minivan over there. So just to give an idea on how big a data center really is. So let's talk a bit more on cloud use cases. So what are now the ideal use cases for cloud? One of the first use cases is what is called on and off. So it's typically a scenario that we see in innovation and development where you you example for example need some services while you are doing the development, or when the developer is at the office, or but typically at night that capacity can be scaled down or entirely shut down. You need it. So, and therefore, cloud is an ideal use case. If you would have that same amount of compute or networking or CPU available, then you would keep on paying for that. Next time, the next use case is a service that is growing fast. For example, if for some strange reason you launched the new Netflix, you launched the new TikTok, or I don't know what's hip and trendy these days, but imagine that if you launch that kind of service and you're running on your own infrastructure or your own data center infrastructure. Imagine that I believe with ChatGPT, it had um, tens of millions of users within the first couple of hours, but ChatGPT wasn't, or it would have been hard to cope with the infrastructure if it was not running on the cloud. Imagine that you have to order a constant batch of hardware and just add it to your own data center. That would be impossible if you have a service that is growing really fast. Third use case is unpredictable bursting. For example, if you launch a new marketing campaign for your service, you typically see a burst in usage of your service. So what you can do with cloud computing, you can temporarily scale that service to a higher level to um, consume more services. And then afterwards, you can scale it down pretty simple, making you only pay what you need. And then there's the last time, it's your predictable bursting, like and we usually see that coming back, especially in retail. Think Christmas, Thanksgiving, summer sale, winter sale, and so on. Those typically have those bursts, and with that, um, if you would run on traditional infrastructure, you would always have to have or buy hardware to really have that peak. While if you were running into the cloud, you can always scale that down when when there's when there's no need for further usage. So let's talk a bit on. So we talked about some of the deployment models or typical use cases. Now let's talk about cloud deployment models. First of all, there's the traditional on-premise where companies or people have their own uh, infrastructure running fully on-prem, so in the data center close to their uh, close to close, close to their business. This is ideal if you have a lot of legacy systems that are running, but typically it's pretty difficult for you as you are responsible for managing the networking, the servers, the middleware, the operation layer. Next to that, you even have to manage the runtime, the data, and the applications. So it's really you're responsible end to end from the ground up till the top. Then the first level of, let us say, cloud is infrastructure as a service. And infrastructure as a service typically gives you the networking, the storage, the service, and the virtualizations um, with a click of a button. So you are not responsible of managing those, but you are responsible for managing the operating system, middleware, and all what you deploy on that infrastructure. Infrastructure as a service is typically a set of VMs, and it's it's usually something that companies um, yeah take as a first step when they move to the cloud. Then there's platform as a service. And this is a real full extraction layer of the underlying infrastructure. So everything is basically managed by the vendor itself. That and this these cloud deployment models um, are applicable to all of the clouds. So even if it's AWS, if it's Azure, if it's Google, if it's Alibaba Cloud, it's basically applicable to all of them. So with PaaS, you get everything up until the runtime from the cloud provider. And it's your responsibility to only manage your application and your data. So let us say that platform as a service is really a next level of maturity when you move to the cloud. It's you focus on the stuff that you're building, you focus on your own application, on your own data. And the next level is my mouse is not working. So the next level is software as a service, and then that's a full extraction layer, and it's typically a software that you buy and where you can define some processes in, or that you just can use as a service. Think of your Gmail account, of your OneDrive or your Dropboxes. Those are typically what is called a software as a service. So you use the service, you use the platform, but there's only a little bit of settings that you can tweak. You have no real impact on the platform itself. So let's take let's go a bit deeper on each of these services. So infrastructure as a service allows organizations to lift and shift their existing on-premise applications and infrastructures to the cloud. As already mentioned, it offers full flexibility of the cloud. It does require organizations to continue to manage their own infrastructure, their own operations, their own systems, and will it will still require technical expertise for tasks like patching, configuration, maintenance of the VMs, and stuff like that. As already mentioned, it's a good first step towards the cloud. However, it's my strong belief that it can result in missed opportunities for optimizing business workloads for the cloud itself. With platform as a service, the need to manage the underlying infrastructure is removed. As said, it allows organizations to rely on the managed offerings of the cloud fully. So this way of deploying an application allows organizations, developers, architects to focus solely on managing their applications and data. And uh, to me, it enhances overall efficiency of building software, building applications, building services for people. Software as a service provides environments, as said, for building, for testing, deploying service, without focusing on, without focusing or managing the underlying infrastructure. A further level of abstraction is software as a service. It's, as already said, it's typically those standard production-ready solution, and it typically focus on one vertical. You can tweak some settings, but the provider handles most of the aspects of the software. Okay, think Office 365, emails, calendars, and so on. So this is again for your reference for using it afterwards to check the different services between them. So here you see an example of what kind of services are applicable when you focus it on Azure. On the left-hand side, there's the least control, and there's also the lowest operational cost. On the right-hand side, there's most of the control, but you also have to take into account that you have the highest operational cost. So with virtual machines, you can deploy custom infrastructure apps, but it requires you to to still manage and patch those VMs at a certain level. On the left-hand side, on the other side of the spectrum, you have serverless, and basically what you need to worry about there is how your code is running on that service. You deploy the code, and basically your code is running. So it's a whole spectrum that you see here, and it's important that when you're building software for cloud or building applications for cloud, you take into account these different settings and choose the thing that is most applicable for you. But it's important to, in my opinion, to embrace PaaS in your cloud adoption. As we previously touched, lift and shift strategies can be a good step towards cloud adoption. However, it can result in missed opportunities for optimizing those business workloads for the cloud. So lift and shift typically offers that quick migration path. It usually, and I've seen that at a couple of customers, it often leads to suboptimal utilization of resources, and therefore it really falls short of optimizing organizations' cloud costs. So organizations may even end up paying more for over-provisioned resources and missing out the potential cost savings when a workload would have been optimized for the cloud. And therefore, it's important to embrace platform as a service offerings within your applications. So, and here are some of the applications or some reference architectures that I've added towards into the deck. Again, this is for your reference afterwards. I do want to leave some time for questions when I look at the time. So this is what a basic web application looks like in Azure. You have app services with an app service plan, and then you have databases underneath, all fully as a service. And you basically, in this case, only have to worry about the website you deploy and about the data you put in your SQL Server. And then there's other architectures like services, web applications, where you really rely on function apps and use a magnificent service called Cosmos DB, which is the summon of cloud databases. So if you want to learn more about that, there's a great set of training on Cosmos DB available online, and it's really an amazing service. And then there's a microservice architecture on Azure Kubernetes services, which again is a further level, but again really comes close to infrastructure as a service, as again you will be responsible for managing more of the infrastructure that you want. Looking at the time, it's time for the conclusion. If you have questions, share them. I don't know how this will work, but share them in the chat maybe, or to the organization. I'll be happy to take them. Also, I will share my email address afterwards, but let's first jump to the conclusion. So the cloud offers a full spectrum of deployment models. So each of them are specific to certain businesses and needs. So as more and more organizations embark on this cloud journey, choosing the right adoption strategy is really key. During this half hour we discussed the difference of infrastructure as a service, platform as a service, and software as a service. And as already mentioned, it's really key for organizations to pick one of those three flavors. So as mentioned, infrastructure as a service provides that flexibility, but infrastructure as a service should be viewed as a temporary step towards cloud. It enables organizations to start their cloud journey, but the ultimate goal should be a transition towards a more platform as a service centric architecture and vision. It provides infrastructure as a service provides flexibility, and really it's almost the same as traditional hosting. Infrastructure is not leveraging the full potential of cloud. By adopting platform as a service and other cloud native approaches, organizations can really focus more on delivering business value and solutions, and really allows them to leverage the full potential of the cloud, ensuring that they're running on the most cost efficient manner. They can use a set of innovative services where we talked on during the start, and it gives them that scalability and improve their knowledge that they need. So embracing the cloud with a well-informed, fit-for-purpose architecture and strategy will empower people and organizations to stay at the edge of innovation and meet the ever-evolving demands of digital transformation. And remember what I mentioned in the beginning, it's the same like with dinosaurs. So if we adopt to this new way of deploying applications, deploying towards the cloud, we as IT professionals will stay relevant in this evolving world of digital transformation. with that said, I thank you for joining. Unfortunately, I couldn't be there with you today. If you have questions, you can drop me an email or can find me on GitHub. Um, I don't know if there's any questions for the room right now. If not, thank you for attending. Um, have a nice rest of the conference and have a nice rest of the weekend. Thank you.
Hey, Glenn, thank you. Do you hear us?
I can hear you, yes.
Perfect. So, thank you, Glenn, for this wonderful talk on the cloud and so on. I'm the MC, so I will just ask if there's any questions which you want
Yes.
answered right now instead of shooting an email to Glenn.
Yeah, that's
Anybody?
perfect as well.
Yeah, we have a question now.
Hi, hi, Glenn. This is Doro from Timisoara. Nice to meet you.
Nice to meet you. Is
Yes,
it possible to speak a bit louder because
yes,
it's
I'm going to speak a bit louder. If you can hear me now.
yes.
Okay. My question is related to the new topic of AI/ML and the open AI services offered on
Yes.
Azure. If you can elaborate a bit on the pricing model, especially for startups and beginning companies that want to use AI, what is the entry point into Azure for this type of development?
Um, I don't know the pricing by heart, but the entry point is really the Azure OpenAI OpenAI service, and you can really start small, and it's important that it's a whole new adjustment of the way traditional software or traditional services has been built. Um, I, I've been talking like during beginning of this week with our quality assurance team on so the way of how to test software is pretty simple. If you have a website, you can run a set of scenario tests and that's it. But with OpenAI, a whole new spectrum opens, and um, typically when you do something with AI, whether it's chatbots, which is or let us say document indexing or building a enterprise search on top of your data, which are, if I'm honest, those are like two big entry points what I see for organization at this point. So typically they're aiming at chatbots, or the second point is they want to have a smart enterprise search capabilities within their organization. So they want to index their documents in their index their knowledge base and have really AI search on top of that, making it easy for their employees or their business. But the issue with AI is that um, it's completely different than traditional software. It's and also another way to test, as typically if you ask something to an AI engine, the answer that comes back will most of the time be different than each time you answer the question, making it difficult to do testing, to do quality assurance and stuff like that. So that's one of the challenges that I see with AI. But AI is also opening up a whole new spectrum and making life easier for professionals. Think of things like GitHub Copilot, really really allowing technical people, architects, developers, um, uh, focusing on those business values and let AI do the boilerplating stuff. Um, so yeah, that's what I see as really entry points within AI. So and I hope that's kind of answered your question at this point.
Maybe we can follow up on the email. Yeah, thanks for your answer, Glenn. I mean, like, we can follow up on email. I have other questions, of course. It's a hot topic here in the discussion.
Yeah, yeah, absolutely. It's and just I've been sharing some things on LinkedIn, and it's quite funny how if you share something that is non-AI, it doesn't get that many traction. If you start talking about AI, everybody jumps onto it. So it's a really hot topic, and it will like get a level of disturbance in our field of work for all of us IT professionals.
Great. Thank you, Glenn. Looking forward to speaking with you. Bye.
Any other questions from Glenn from the room, please? Glenn, no more questions for you, my friend.
Okay, thank you again for having me. If there's anything, questions that come up, reach out to me and I'll be happy to help you.
Yeah, just hang on the connection for 30 more seconds because these people want to applaud you.
Thank you.
Thank you.
See you soon. Bye-bye.
See you guys. Oh, Glenn, bye. Okay.